Well, here we are trying to figure out what kind of scientists don't do experiments. And so, in your Did You Get It questions at the bottom of this lesson, there are several questions. One is, what are the two basic types of science? I've got one listed here, experimental. We finished studying that. The other is to be named. And we know how experimenters do their thing. Here's abbreviations for the 5 steps in the logical flow of the scientific method. And so I did put test here instead of experiment because we're going to find there's more than one kind of test for hypotheses. But then the second part of number 8 down below says, what are examples of each? Well, chemistry, some of you had chemistry class, you do lots of experiments. Physics, that's physics, not physic. And, that's for the real nerds, right? I have to confess that in a previous lifetime, way back in the 1960s, I got a bachelor's degree in science, majoring in physics. Can you believe that? Anyway, medical drug research, that's also an experimental science. And so, what are the differences between this and the unnamed science? One of them will be the basic question. And so that's the question 9. What's the basic question of each type of science? What are the experimenters attempting to do? They're attempting to study a process. Study a process, a chemical process, a physical process. How does a drug operate and so forth? The basic question they're asking takes this form. How does it work? How does it work? How does that chemical reaction work? How does that drug work? How does that physical process work? How does it work? And we know how they test their hypotheses. We've been through that. An experimenter does experiments, right? That's why it's called experimental science. Knowledge advances by the conduct of experiments. So what is this other type of mystery science over here that does not require experiments? Or really, experiments really are pretty much irrelevant. And that is called historical science. Historical science. Let's name some examples. You study old rocks. What are you? You're doing geology. You study dinosaur bones. What are you doing? You're doing paleontology. And if you study ancient civilizations that are just with us in the form of ruins and so forth, you are doing archaeology. And let me suggest, we can name more, but I will suggest one that maybe you might not think of. When I drive to work in the morning, sometimes I see historical scientists by the roadside examining a couple beat up cars and the banged up cars. And the historical scientists, they have their uniforms, they have their vehicles, special vehicles. There's usually a light on the tops going blinky, 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 and they're trying to figure out what went down here with these 2 cars that are banged up. And some of their colleagues might be called detectives, and they're investigating other type things. What type of science are we talking about here? I think it's called forensic science. And so there's many more that can be named, but anyone who's attempting to reconstruct history is a historical science. And so let's write that down. What are these guys trying to do here? They're trying to study a process. What are these folks over here basically attempting to do? They are attempting to reconstruct, boy, I can't spell at this angle. They are attempting to reconstruct, that's pretty bad, reconstruct history. And what that's supposed to say is reconstruct history. I probably need to reconstruct that word. But historical scientists are attempting to reconstruct history. And so their basic question takes a different form. We're talking now about the basic question, and that is, it would go something like this. How did it come to be this way? How did it come to be this way? How did this geologic formation come to be this way? How did this ancient civilization come to be this way? How did these 2 banged up cars come to be this way? How did it come to be this way? So a different basic question. So that is one of the differences between historical and experimental science, a different basic question. But also another difference is how hypotheses are tested. Let's think about a typical CSI program. If you see how they do their thing, then you can kind of relate to how all historical scientists test their hypotheses. At the beginning of a CSI program, what happens? One or more deceased individuals are discovered. Then after the first commercial break, flurry of activities, CSI folks pull up in their van, they get out, they have their little kits, they put the kit down, they open it up, put on their gloves, and get out their shiny little flashlight, and they start doing what? They start making observations, and they're pretty good at that. They can find all kinds of things. One thing they might possibly find is DNA evidence at the crime scene. And so do they develop hypotheses on the CSI program? Sure they do. Let's say the hypothesis is that Joe shot John. Now if it's the first hypothesis in the show, it's probably wrong. But let's say it's the second or third, and let's say the hypothesis now is that Joe shot John. And so let's say that poor John, of course they got poor John, let's say the CSI folks found some DNA evidence on poor John that didn't belong to John. Somebody else's DNA, probably or possibly the perpetrator of the crime. And they think Joe shot John, so they do their best to get a hold of Joe, and they do. Let's say they get a hold of Joe, they're going to get some of his DNA, right? And what are they going to do to Joe's DNA and the DNA found at the crime scene that didn't belong to John? You better believe they're going to compare it, right? See if it matches. And so that is the basic way that hypotheses are tested by historical scientists, by doing comparisons, or what is called the comparative method. The comparative method. And so if you watch a CSI show, if you think about it, you'll see lots of comparisons. Fingerprints are being compared with other fingerprints. DNA, of course, with other DNA. Tire prints with tire prints. Footprints with footprints. Bullet striations with other bullet striations. Comparison after comparison, all leading to a conclusion, which is always helped along by the tearful or angry confession of the accused. You kind of like them to shut up. Maybe they get off, but no, they don't. Anyway, that's not the point here. The point is we have a test that is different. And so two differences, basic differences between experimental and historical. A different basic question, how does it work, versus how did it come to be this way, and a different way of testing hypotheses, experiments versus comparisons. And so does that apply to these other types of historical scientists? Sure, if you think about it, if you watch some Discovery Channel shows, you'll see lots of comparisons. I'm kind of an archaeology wannabe, I'll put it that way. If I had another 100 years or so, I'd probably study to be an archaeologist. I love reading about it. I get a magazine I enjoy reading. And what do they do when they have an ancient site? They dig down through the various layers of civilization on that site. And what's one thing they're very interested in the various layers? Well, one thing would be how old each layer is. Is it 1,000 years old, 1,500 years old, or what? Sometimes they find distinctive pottery in a certain layer. Now, it could be they found the same kind of pottery elsewhere. What are they going to do? They're going to compare the pottery from this new site with a pottery maybe from another site where they've already figured out how old that is. And that comparison there will help them date. Again, testing a hypothesis of age by comparison. And so, hey, that's what it's all about. Experimental versus historical, the two different ways of doing science. And that's the story. Okay.